Welcome everybody to Management 670 Business Analytics. And today we will be talking about summarizing, describing numerical data, descriptive statistics. So let's get started. Start off with what is business analytics? It really is just interpreting data. It's collecting it, sifting through it, sorting it, processing it really into information and really strategic decisions. You make smart decisions with data is the point and goal of business analytics. As you can see from the table, all areas of business are affected, from accounting to finance to human resources even. Today we're going to take a look at the central tendency, which is the single value that pinpoints the center of a data set. If you have a collection of data points and figures, how do you describe that data? Well, you start with talking about the middle, center, a single point that represents its data set. The most common, and what most people think of, is the mean. It is, of course, a measure of the central tendency. And it can be thought of as kind of like the balance point, directly in the middle. But it is affected by extreme values known as outliers. Large values, or very small values, can push the mean away from what you would think of as the best representation of the center. As an example, we have 6 values over here. Say we collected that from some sales data. N is our sample size, so we have 6, so that's N equals 6. And then you take the sum of these 6 values in the numerator and just divide it by the sample size N. So the mean of this data set of only 6 values is 8.3. As opposed to the median, it's also a very common measure of the central tendency, but it is primarily concerned with the middle. You have to have an ordered sequence to find it. There are 2 cases. The first one is that you have odd number n for an odd sample size, like 5 over on the right. And then it's simply just the middle value in that sequence. Or if you have an even number of sample size, then you just take the average of the 2 middle values. It is, unlike the mean, unaffected by the outliers. We have 5 data points right there in the sales data. We first have to order them ascendingly, so smallest to largest. Since the sample size is 5, that's odd. We can just add 1 divided by 2, find out that the third value in the ordered set would be our median. As opposed to this even set, where I have now 6 values, so n equals 6. I can add 1 to that and divide by 2, but that means the median is 3.5. To find that value, we take the third and the fourth value, just find the middle, add them together and divide by 2, also 8.3. Next discussion is quartiles. You can think of an entire range of data set chopped up into 4 equal pieces called quartiles. Q1 shows the first 25% of the data. The difference between Q1 and the median, which is also known as Q2, is 25. From the median to Q3 is 25% as well. And finally, 1/4 of our data will be greater than our third quartile, Q3. That position of the quartile can be found right there by I times n plus 1 divided by the 4. Let's look at an example. Slightly larger data set. We have 6 here instead of 5. We order it, again ascending, so smallest to largest. I want to find that division between the first 25% of the data and the last 75%. Through the formula, we find out that the position is 1.75. That means we have to weight the second value 3 times more than the first one to get the representation of 1.75. That calculation is 5.95. There's an easier way. Who wants to add a bunch of values together on a calculator or even in Excel? We want to use Minitab, which is a built-in statistical software that specializes in this. So I'll flip to the calculation itself. Minitab is easily editable. So we have our labeled data here for sales, and then our 6 points from before, 10.3 all the way to the 7.7. For Minitab, we can go into Stats tab at the top, Basic Statistics, and I want to display descriptive stats. There are a bunch of options here, but a nice feature of Minitab is it's point and click. So if I did not have a list of variables that I wanted to describe, I could just double click on C1 in sales, shows up right here, and I have options on the different types. We'll talk about all the different types later, but for right now, I'm most interested in the mean, first quartile, the median, which is the second quartile, Q2, third quartile, as well as some other descriptive values, including the minimum and the max. Hit OK, and our output shows up just like this. One note is that our sample size is n. In large data sets, you might have blank values, and those are represented by n star right there. But in our case, we just had 6. All of them were present. And now we have our previously calculated mean of 8.3 and our median value, which happens to be the same as 8.3. Our 5.95 is Q1, and Q3, if we followed that positioning calculation, would be 10.65. To bracket in our quartiles, we have the min value here, 4.9, and our max is 11.7. This is a nice, fast way to describe 6 data points, but it's just as easy if you have 6,000 data points. I've taken some screenshots to show the flow from entering the data in column C1, adding the label, and having our output right there in the lower right. Here's a challenge problem. Let's assume you're a financial analyst at Craner Securities, and you've collected some data about closing stock prices, and they're listed here, from 17, 16, all the way to 11. How would you describe the central tendency of this data set? Well, you could do it in one of 2 ways, but both are really applicable. You could take the mean of the entire data set and find out that it's 15.5, but I could take a look at the median as well. Since it's an even sample, I need to average the middle 2 values. In this case, they're both 16, so that's pretty easy. So I find out that the median is 16. This is a good point, that the mean and the median don't necessarily equal one another. Q1 calculation shows about 2.25. So if we calculate that, we can have a Q1 value of 12.25, as opposed to Q3, which is 6.75 of the ordered rank. That translates into a calculation of 17.75. These are all ways to describe the underlying data set. I have 2 practice problems at the end of this slide deck. Practice problem number 1 right here is about waiting times. Practice problem 2 is about reward, and more calculations about the central tendency of a data set that you might not be familiar with. So in conclusion, to start off by describing data, we have to talk about a central point, and that's a central location. Thank you.